Example 9, the body surface area of a human being is used to determine doses of medication. Formula for finding BSA is, BSA equals the square root of HM over 3600, where H is the height in centimeters and M is the mass in kilograms. A doctor calculates a particular dose of medicine for a patient whose BSA is less than 1.9. If the patient is 100 centimeters tall, what must the mass of the person be for the dose to be appropriate? So, first off, they give us a formula, and they do this a lot in math word problems. They'll just say, here's a formula, has all these letters in it, and within the words they tell you what all the letters represent. So that's the first thing I'm going to look for in this problem. So if I get my highlighter out, start highlighting things. Here's my formula here. The body surface area is BSA. So BSA is one variable representing the body surface area. They don't give us any type of unit on this. I believe it's meters squared, but don't hold me to that, but I'm pretty sure it's meters squared is the unit on body surface area. They're not giving it a unit. Notice a patient whose BSA is less than 1.9. So they're not giving a unit, that's fine, but I'm pretty sure it's meters squared. H is the height in centimeters of the patient. Okay? Not only does it say it's height, but height in centimeters. So when we start reading through the stuff, if they give us the correct unit, we're in good shape. If not, we're going to have to modify. But it says the patient is 160 centimeters tall. They give us a height in centimeters, so that's H. So again, it doesn't say right here H is 160, but they told you what H represents, and they're giving you the height in centimeters. So they're giving you H in that case. And finally, M is the mass in kilograms. What must the mass of the person be? They're asking you to find M. So they're giving us the BSA, so 1.9 goes there. They're giving us H, 160 goes there. They're not giving us M, we're leaving M a variable. And this formula here is all we need, right? Now it says the BSA is less than 1.9. Let's just, for the sake of making this problem easier to deal with, pretend it doesn't say is equal to. Let's say it says it's equal to. We'll deal with the less than in a minute. So this patient's BSA is less than 1.9. We're just pretend it's equal to 1.9. So if the BSA equals 1.9, so 1.9 goes where BSA is, square root of, there's a 3600 on the bottom, and there's an HM on top. H is 160, M is unknown. So I simply replaced BSA with the number they told me BSA was. I replaced H with the number they told me H was in the formula they gave me. Okay. Once I do that, I now have a equation here with a single variable M, which represents the mass, which is what they're asking me to find. Now, this particular formula, I believe this is the exact formula. Don't quote me on that, but I'm pretty sure that's the real formula for body surface area of a human being, if you know their height in centimeters and their weight or their mass in kilograms. I'm pretty sure that's it. And again, I'm pretty sure it's meters squared, but it could be feet squared, but it seems like meters squared, just in my mind, that's what it is. I don't know if you guys know this or not, but I'm going to tell you real quick. The square root of 3600 is 60. Just at 60 times 60 is 3600. So if 3600 is in this formula inside the square root on the bottom of this fraction, I could legally take the square root of 3600 on the bottom and leave the square root untouched on top as I do that. That is legal. When you deal with fractions, square roots, the square root of the top and the square root of the bottom are separate entities. The square root of the bottom can be evaluated exactly. It's no longer a square root on the bottom. Now it's just a normal looking 60. And then the square root of 160m, I'm not simplifying that or fixing it. I could pull some stuff out, but I'm fine with it like that for what we're doing. All right. But to this point here, with square root is being divided by 60, I'm going to put this over 1. I'm going to go ahead and cross multiply. So this product, which is 1 times the square root of 160m, better known as the square root of 160m, equals 1.9 times 60, which is 114. If you didn't know that 1.9 times 60 is 114, grab a calculator, punch in 1.9 times 60 equals. That's what happened earlier today when I did it. It said 114. That's how I knew it was 114. All right? So use a calculator to calculate as you need. All right, now, at this point, I've got a square root equals number. There's nothing attached to the square root, right? There's nothing times divided by add or subtract to the square root. So now I'm at the point in all these square root problems where I'm going to square this side to get rid of the square root, I gotta square that side as a consequence. The left-hand side just gets rid of the radical, so I'm gonna get 160m. The right-hand side, I have to square 114, which 114 squared equals 12,996. There's no reason any one of us should know that 114 squared is 12,996. Ask your calculator, it will tell you. It's the worst secret keeper ever. You ask it a question, it always just blabs the answer. So, just got to type it in right. And finally, if I want to get m equals, what do I got to do?
Divide.
Divide. That's 160m, so I'm going to divide by 160 to get rid of that coefficient. So 12,996 divided by 160, 1,996 equals 81.225. So the BSA is less than 1.9. The mass of the patient must be at least 81.225. So the patient, in order to, because you want to make sure the patient doesn't get too much medicine, right? So if their BSA is exactly 1.9, they should be exactly 81.225 pounds. If they're less than 1.9, that means their mass is actually less than that number, right? Okay. We'd want their mass to be greater than or equal to that number to ensure that they're a big enough mass to take in the medication they're supposed to get. So I would say the mass is greater than or equal to 81.225 kilograms. If I said mass less than, maybe they're 20 kilograms, and all of a sudden we're giving them this big dose of medicine for somebody who's 81 kilograms, right? So we want to ensure they're not getting too much medicine. We're going to make sure their mass is bigger than that number to account for that.